All right, lesson 2.6, rational functions. This is a big lesson. There's a lot going on in this lesson. All right, there's 3 examples, but in each of these examples, there's a lot going on. So if you have any questions, please make sure to ask. First of all, we're working with asymptotes, a line that a graph approaches, and it could intersect it once, or it never touches. Okay. Now, vertical asymptote. When working with rational functions, to find the vertical asymptote, we simply find the zeros of the denominator. It's as simple as that. For the horizontal asymptotes, there's a lot more going on. All right, you have to look at the degree of both the numerator and the denominator. All right, if the degree of the denominator is greater than the numerator, then your horizontal asymptote is simply y equals 0. If the degree of the denominator is less than the numerator, then there is no horizontal asymptote. And if the degrees are equal, then the horizontal asymptote is the ratio of the leading coefficients. All right, and you'll see each of these come up in the examples. Okay, so let's dive straight into the big ideas of this lesson. Find the domain of the function, decide if the function is continuous, and identify any horizontal and vertical asymptotes. Okay, first thing, domain. What is domain? All right, you have to understand it by this point. If you don't, let's make sure we understand it now. Domain is simply the x values that work for the function. So let's just look at this expression. What x values don't work? All right, that's what you want to look at. Well, what do I mean by that? What makes this expression undefined? Well, if you plug 0 in here for x, the whole thing becomes, if you plug in 2 for x, the whole thing becomes 0, and you get undefined. And that's the only x value that creates an undefined expression. All right, so the domain is all row numbers because any value of x will work in this function except for what? X equals 2. All right, so the domain is all row numbers except x equals 2. How about for the next one? Well, what makes this expression undefined? In other words, when is the denominator equal to 0? Well, just set the denominator equal to 0 and solve it, and you'll get x equals negative a half. So it's all row numbers except x equals negative a half. Alrighty? And then for the next one, same deal. What makes the denominator 0? What makes the expression undefined? It's all row numbers except x equals negative 1. All right, now are the functions continuous? Continuous means there are no gaps in the domain. All right, no gaps in the graph. Well, in this case, we have a gap, so it's not going to be continuous. There's a gap in the domain once again, so it's not going to be continuous. There's a gap in the domain once again, so it's not going to be continuous. Now for vertical asymptotes, all right, very simple. Set the denominator equal to 0 and solve. So your vertical asymptote is x equals 2. Once again here, set the denominator equal to 0 and solve. And for the next one, same deal. All right, so the gap in the domain is essentially where the vertical asymptote is coming through. All right, now for the horizontal asymptotes. This is where you got to go back to the properties that you have, the 3 properties or the 3 scenarios, all right, and see what it matches up with. Well, if we look at the degree, what's the degree here? The degree here is 1. What's the degree here? The degree is 0 because there's no variable, x to the 0th power. So if the degree of the denominator is greater than the degree of the numerator, then our horizontal asymptote is y equals 0, which we have in this case. Now look at the degrees here. All right, sort of out of order, but the highest degree here is 1, the highest degree here is 1. So in this case, you simply take the leading coefficients, which is negative 5 and 2. And that represents your horizontal asymptote. For the next one, we have the degree of the numerator is greater than the degree of the denominator. If this is the case, then there is no horizontal asymptote. All right, if you have any questions on this right now, please make sure to raise your hand and call me over so I can clarify things for you. All right, going on to the next example. Let's get into the graphing now. All right, first thing, find the domain. Well, once again, what values are not included in the domain? What makes this undefined? Well, that's going to be 3. So it's all real numbers except x equals 3. All right, well, there is a gap in the domain, so it's not continuous. Now, figuring out the x-intercepts. How do you figure out the x-intercept? You set the opposite variable equal to 0. Set y equal to 0. Remember, y is the same thing as f of x. All right, and then I can multiply by x minus 3 on both sides. And you'll notice that the x's disappear. All right, we get 0 here. So there is no x-intercept. And then for the y-intercepts, we set x equal to 0. So we're going to have y equals negative 1/3. So our y-intercept is at the point 0, negative 1/3. All right, now for the vertical asymptote. That's very simple. Set the denominator equal to 0, so x equals 3. And then the horizontal asymptote. All right, this is where you got to look at the 3 scenarios. The degree of the numerator is 0. The degree of the denominator is 1. So in this case, our horizontal asymptote will be y equals 0. No work involved. All right, now for graphing. What do we do? First thing you're going to do is graph your asymptotes. Now when you're graphing asymptotes, you don't use a solid line. You're going to use a dashed line. So we have a vertical asymptote of x equals 3. Here we go. All right, and horizontal asymptote of y equals 0. Okay, now what do we do? Okay, you're going to choose some x values. You're going to choose one x value to the left of the vertical asymptote and one x value to the right of the vertical asymptote. Very easy x value to work with. To the left is 0, and then I'll choose 4 to the right. All right, plug these in to your function and work out the y value. So I end up with negative 1/3, and then I also end up with 1. All right, so 0 and negative 1/3. 0, negative 1/3, that's right about here. All right, now what does this mean? This means that the graph lies in this particular region between the asymptotes. So it's going to be like this. It's going to be up against the asymptote and then come down. There we go. All right, and then you have negative 1/3. Let's see, 0, negative 1/3, we just did that. Then you have 4, 1. Over 4, up 1. All right, now what does this mean? It means that our graph is bounded by the 2 asymptotes in this region. So it looks like that. It just follows the asymptote, goes up against it. All right, and that's our graph. What you have in the blue there represents your graph for the rational function. All right, let's go do another example. All right, figuring out the domain. Once again, just set the denominator equal to 0. And it's all real numbers except x is equal to 1. All right, continuous. There's a continuous. No, there's a gap in the domain. X-intercepts, set y equal to 0. All right, multiply by 1 minus x on both sides. It's a little scrunched here. All right, so I end up with 0 here. So I get 0 equals 1 minus 3x. And if you solve for x, you get 1/3. So you'll be at the point 1/3, 0. All right, and then for the y-intercept, I will have y is equal to 1 minus 3 times 0 over 1 minus 0. And that's y equals 1 then. when it simplifies. So that's at the point 0, 1. All right, now for the vertical asymptote, what's going to happen here? All right, so you set the denominator equal to 0, and we have x equals 1. Vertical asymptote is simple. All right, set the denominator equal to 0. Now for the horizontal asymptote, we have to look at the degrees. What's the degree? The degree here, the highest, is 1, and on the bottom it's also 1. All right, since the degrees are equal, we take the ratio of the leading coefficients. So -3 over -1. -3 over -1 is 3. Okay, now for the graphing. Graph your asymptotes. So, vertical asymptote is x equals 1. All right. All the x values on this line are 1. And then my horizontal asymptote, y equals 3. All the y values on this line are 3. Okay, now what do? That's right. Test some x and y values. So I'm going to choose 0 once again. That's the easy one, and I'll choose 2. All right, plug them in to the function, figure out the y value. I get 1, and then I get 5. Okay, so graphing my rational function now. 0, 1. Here I am. All right, that means I'm in this bottom left region. So here's my graph. Just goes up against those asymptotes. And then you have 1, 5. Or sorry, 2, 5. Or 2 up 5. All right, once again, the graph just goes up against these asymptotes. All right, if you have any questions so far, please make sure to ask. And on to the final example. All right, there's vertical asymptotes, there's horizontal asymptotes, and then there are slant asymptotes. Okay, now when do you get a slant asymptote? Well, you get a slant asymptote when the degree of the numerator is higher than the degree of the denominator. Let's see how this all works out. Domain, once again, all row numbers in this case except, well, it makes the domain 0. 0. All right, continuous, nope. X-intercept, set y equal to 0. And I get x squared plus 5 over x. All right, multiply by x on both sides. All right, and I get 0 from this, so I get x squared plus 5 equals 0. I'm a little scrunched here, sorry. Subtract 5. And I get x squared equals -5. You should already see where this is going. If I take the square root, that's not happening. I don't have any real x-intercepts because I'm going to get an imaginary number, right? So there are no real x-intercepts. You can't graph that on the regular Cartesian plane. All right, then you have y-intercepts. Y is equal to 0 squared plus 5 over 0. Then you have all right, well, we're dividing by 0 here, so this is undefined. So we have no y-intercept either. All right, now for vertical asymptotes, you set the denominator equal to 0, so it's just x equals 0. And then horizontal asymptotes. What happens here? Okay, there's a little bit of a process when you're figuring out the slant asymptote. Okay, I know I have a slant asymptote now because the degree of the numerator is higher than the degree of the denominator. So what do? You're going to have to do long division. Yep, that's what you got to do. All right, you're dividing x into x squared plus 5, so don't forget the 0 coefficients. All right, let me scoot down here a little bit. All right, so do your long division. All right, got this. Yep. Okay, so now what do I end up with? I end up with x as my quotient plus 5 over, what's my divisor? X. Okay, and now what you're concerned about in this problem is your slant asymptote, and my slant asymptote is whatever my quotient was, right here. So my slant asymptote is y is equal to x. Alright, now let's graph the asymptotes. X is equal to 0. So here I am, all the points on this line, the x values are 0. Alright, now y equals x. Alright, very simple. What's the slope of this line? 1 over 1, right? Alright, so we start at the origin, go up 1, right 1, up 1, right 1, up 1, right 1. So here I am with my slant asymptote. Okay, now, once again, what do? Alright, you figure out some points to the graph. Alright, so I'm going to choose -1 and 1. Alright, if I plug those in, I get -6, and I get 6. Alright, so at -1, for x, we're down at -6. Alright, and then for +1, we'll go up 6. Alright, so now that means that the graph is bounded by the asymptotes in these regions. So here's my graph. It's going to do something like this. Alright, so the graphs are starting to get much more interesting now, right, when you graph them. Alright, so not that difficult once you understand what to do. You will be allowed to use the yellow chapter summary sheet, so you don't necessarily have to memorize the properties, although memorizing the properties allows you to be more efficient when you're doing your work. Once the benchmark comes around, though, you can't use the yellow sheets, so you have to really understand how these problems work and have the properties dialed in. Alright, if you have any questions, please let me know. Begin the assignment at the bottom of the webpage.